Usually when we talk about getting a medical diagnosis, there's this deep expectation of precision.
Oh, absolutely.
Like if you break your arm, the x-ray shows that jagged white line right on the screen. The doctor points at it, says, there's the fracture, and you get a cast. It's binary. It's just clean.
Yeah, and it's comforting, really. We kind of rely on that clarity. I mean, we want our health to be neatly categorized so we know exactly what we're fighting.
Right. But the moment you step into the world of inflammatory skin conditions, that pristine x-ray machine just sort of shatters. You find yourself navigating a diagnostic landscape that is entirely murky. And today we are wading directly into the center of those muddy waters for you. We're doing a deep dive into a highly debilitating chronic condition called lichen sclerosus, or LS for short.
Yeah, and this condition really is like the epitome of diagnostic ambiguity. Lichen sclerosus primarily affects the genital area, so the vulva in women and the penis in men, though, I mean, it occasionally appears in other parts of the body, too.
Which is awful.
It is. Physically, it presents as these pale, white, atrophic patches of skin. It drives this intense, maddening itching and soreness. And if it's left unchecked, the scarring can become so severe that it actually distorts the local anatomy.
Wow. The physical and emotional toll this takes on the people living with it is just staggering. And if you or someone you know is dealing with LS, you've probably done some late-night researching, and you've likely seen it tossed casually into the autoimmune bucket.
Right, the usual narrative.
Yeah, the narrative is usually that your body is just attacking itself. But here's where it gets incredibly fascinating. The medical community is currently locked in this massive debate about what is actually driving this condition. So the central question we're exploring today is lichen sclerosus actually a true autoimmune disease?
Or, is the immune system just reacting to a completely different culprit?
Yeah.
That is really the dividing line in dermatology right now.
Yeah. Exactly. So to get you an answer, we are pulling apart a huge stack of clinical, genetic, and molecular evidence today. We're looking at the latest European and British dermatological guidelines.
The Euroguiderm and BSSVD ones, yeah.
Right, those, plus NHS patient leaflets, pathology reviews, and this groundbreaking 2026 genome-wide meta-analysis. We want to figure out if the immune system is the instigator here, or if maybe we've been pointing the finger at the wrong suspect entirely.
Well, to understand why doctors have historically labeled LS as an autoimmune disease, we first have to kind of look at the macro picture, right? The patients themselves. It's a classic case of guilt by association.
Guilt by association, okay.
Yeah, because when you look at the clinical data, about 1 in 4 people diagnosed with LS have another recognized autoimmune disease.
Wow, 1 in 4. That's a huge overlap.
It's massive.
Yeah.
And it isn't just a random assortment of immune issues either. The most common comorbidities are autoimmune thyroid diseases, specifically Hashimoto's thyroiditis and Graves' disease.
Okay. Yeah, thyroid issues are so common.
Extremely. And we also see notably higher rates of things like vitiligo, alopecia areata, pernicious anemia, and even type 1 diabetes.
There's a whole cluster.
Exactly. Furthermore, the pattern actually extends beyond the individual patient. There's a deeply entrenched familial link. Between 12 and 15% of female patients have a first-degree relative with the condition.
Oh, wow. So you're looking at a clear clustering of autoimmune conditions within a single patient and a clustering of the disease itself across the family tree.
Right.
So if a condition runs in families and constantly hangs out with other autoimmune diseases, you naturally have to assume there's a shared genetic blueprint at play. Which brings us to that massive 2026 genome-wide association study we mentioned.
Oh, that study was incredible. They looked at hundreds of thousands of participants across European biobanks.
Hundreds of thousands. And out of everything they analyzed, one specific genetic finding stood out above the rest, right? It was a gene variant called the, let me get this right, HLA-DRB1 star SAR, 12.01 allele.
You got it.
Nice. And it showed a massive association with LS susceptibility.
It did. And to understand why that specific allele is essentially the smoking gun, we have to talk about what the HLA system actually does in your body. Human leukocyte antigens function as your immune system's targeting mechanism.
Like radar.
Exactly like radar. They present proteins from inside your cells to the immune system on the outside. It's literally how your body differentiates between your own healthy tissue and foreign invaders.
Okay, so if your targeting system has a genetic quirk, it might start flagging your own cells as the enemy.
Precisely.
So if we think about the body's genetics like a massive city, having this HLA variant means you've essentially moved into the autoimmune neighborhood. And if you buy one house there, say, the thyroid disease house, you're statistically much more likely to buy the house next door, which just happens to be lichen sclerosus.
That's a great way to put it. The clustering isn't a coincidence. It points to a foundational immunogenetic vulnerability. The patient's immune targeting system is just miscalibrated right from the start, making them highly prone to these self-directed inflammatory responses.
But, hanging out in a bad neighborhood doesn't automatically make you a criminal. Like, just because a patient has a genetic vulnerability in a bad thyroid doesn't definitively prove that the skin condition itself is an autoimmune attack.
Right, correlation isn't causation.
Exactly. To answer our core question, we have to look for the actual biological weapons the body might be using against the skin.
We have to move from the patient history down to the microscopic level. If this is a true autoimmune disease, we shouldn't just see genetic risk. We need to actually find the specific autoantibodies in the blood and tissue, and we need to know exactly what they're trying to destroy.
And researchers found them. When analyzing the blood of LS patients, they found these circulating IgG autoantibodies against a protein called extracellular matrix protein 1, or ECM1.
Yes, the ECM1 antibodies.
Yeah. And they found them in a staggering 75 to 80% of the patients they tested.
Which is a huge majority. And remember, autoantibodies are essentially rogue immune proteins. Instead of neutralizing a virus, they're programmed to hunt down and attack your own biological structures. And in this case, they've locked right onto ECM1.
Let's visualize what ECM1 actually does, because that perfectly explains the physical symptoms of LS. Like, if our skin is a brick wall, ECM1 operates like the structural mortar holding those bricks together, right?
That analogy perfectly captures its function, yes. ECM1 is a glycoprotein that regulates the assembly of collagen. It binds different structural molecules together, effectively anchoring the top layers of your skin to the deeper tissue below. It maintains the integrity and the elasticity of the skin.
So if the immune system is actively sending rogue antibodies to just dissolve its own structural mortar, it makes total sense that the skin would lose its elasticity, thin out, and eventually scar over as the body just desperately tries to patch the failing wall.
Exactly. But it isn't just antibodies doing the damage. When researchers look at biopsies of LS skin, the tissue is practically swarming with inflammatory killer T cells.
Oh, wow. So it's a coordinated attack.
Very coordinated. We see a very specific, aggressive immune response localized right in the genital skin. But honestly, the presence of these T cells isn't even the most fascinating part. It's why they are allowed to attack unchecked.
What do you mean unchecked?
Well, normally your immune system has regulatory T cells, TREGs, for short, which act as a braking system. They patrol the body and suppress any immune cells that get a little too aggressive toward healthy tissue.
Okay, so if the regulatory T cells are the brakes preventing friendly fire, it sounds like those brakes are just failing in LS patients.
They aren't just failing, the brake lines are being actively cut.
Oh, man.
Yeah. We can trace that back to a specific molecule mentioned in the European guidelines called microRNA 155. In LS patients, this microRNA is massively overproduced. And its primary function in this context is to suppress those regulatory T cells.
So it's biological sabotage. The microRNA neutralizes the peacekeepers, which allows the inflammatory killer T cells to swarm the skin without any opposition.
Exactly, which results in a chronic, localized inflammatory attack. And to solidify how central this specific attack is, we can look at a rare genetic disorder called lipoid proteinosis.
Oh, I saw this in the notes.
Yeah, people born with this condition have an inherited mutation in the exact same ECM1 gene we just talked about.
So their body just doesn't build the mortar correctly from birth.
Correct. And when you look at their skin under a microscope, the structural damage looks virtually identical to lichen sclerosus.
That's crazy.
Right. It confirms that the disruption of ECM1, whether caused by a genetic mutation at birth or by an autoimmune attack later in life, leads to this very specific pattern of scarring and atrophy.
Okay, I mean, this feels like an open and shut case. You have the genetic predisposition, the rogue antibodies targeting the skin's structural mortar, and a localized T-cell attack where the biological brakes have been literally cut. The immune system is clearly the arsonist setting the fire here. So why is there even a debate?
Because of a massive plot twist emerging in dermatological research right now.
Ooh, I love a plot twist.
Well, what if those autoantibodies aren't the arsonist at all?
Right. This is where the diagnostic waters get incredibly murky. Because some researchers argue that the ECM1 antibodies might just be what do they call it, an epiphenomenon?
Yes. The theory posits that the immune system isn't initiating the attack. Instead, it suggests that a completely different mechanism is breaking down the skin first, specifically local oxidative stress.
Let's unpack oxidative stress for a second because it gets thrown around a lot in health articles, usually right before someone tries to sell you a blueberry supplement or something.
Very true.
So what is it actually doing to the skin at a cellular level?
Well, at a fundamental level, oxidative stress occurs when there's an overload of highly reactive, unstable molecules called free radicals in your tissue. And because these molecules are missing an electron, they violently steal electrons from neighboring healthy cells.
They should rip them away.
Exactly. They rip apart lipids, they damage DNA, and they alter the physical 3D structure of proteins in the skin.
So it's literally degrading the cellular architecture.
Yeah.
So if oxidative stress is destroying the skin first, are these autoantibodies not the arsonists who started the fire? Are they just the firefighters and the cleanup crew who showed up after the building was already collapsing and now they're being blamed for the destruction?
That is the exact debate. The immune system might simply be responding to the wreckage. When oxidative stress severely damages the skin, it physically breaks apart the cells. This process can essentially unmask hidden proteins like ECM1, which are usually tucked safely away inside intact tissue.
Oh. So the immune system is patrolling the area, sees this newly exposed altered debris, and because it doesn't recognize it, assumes it's a foreign invader.
Precisely. It mounts an antibody response against the debris to clear it out. So in this scenario, the autoimmunity is a secondary reaction, a symptom of the tissue damage, rather than the primary cause of the disease.
That makes so much sense. And the strongest piece of evidence supporting this firefighter theory is the incredible gender discrepancy in LS, right?
Yes, the numbers are wild.
It is up to 10 times more common in women than in men. That alone is a stark divide. But the comorbidity data is what really reframes the whole autoimmune question for me.
It really does. The difference in the clinical profile between men and women with LS is just astronomical. While up to 54% of females with the condition have associated systemic autoimmune diseases like the thyroid issues we discussed earlier,
Right.
only 3 to 5% of males do.
Over half of the women in some clinical cohorts have another autoimmune disease compared to almost none of the men. That's a huge gap. And that massive 2026 GGY study noted that while the genetic HLA links were present in both sexes, the effect sizes were significantly diluted in men.
Which forces us to ask a really difficult question. Are we even looking at the exact same disease process in men and women?
Wow.
Yeah. It's highly probable that in men, LS is driven almost entirely by local tissue damage and oxidative stress. The immune system just reacts locally to the debris. But in women, they have that heavy systemic autoimmune vulnerability driven by their genetics.
So for a woman, the initial damage might still be required, but her genetically primed immune system overreacts catastrophically, fanning the flames way beyond the initial injury.
Exactly. The systemic autoimmune response becomes a massive amplifier.
Which brings us to the most practical question for you listening. If systemic autoimmunity isn't the sole driver, especially in men or in isolated cases without a thyroid connection, what actually pulls the trigger? What causes that initial localized oxidative stress?
Well, the guidelines point to several environmental and mechanical triggers, and they actually all perfectly align with the theory of localized tissue damage initiating the cascade. A primary example is something dermatologists call the Koebner phenomenon.
Which is when skin lesions specifically develop on areas of previous trauma or chronic friction, right?
Yes. For LS, the disease frequently erupts exactly where the delicate genital skin has been subjected to repetitive mechanical stress. The sources highlight things like tight clothing, horseback riding, or prolonged use of bicycle saddles.
Okay, so the constant friction creates micro tears in the tissue, but mechanical stress isn't the only culprit. The guidelines deeply emphasize chemical irritants too, specifically exposure to urine.
Yeah, they refer to it as microincontinence. We aren't talking about full loss of bladder control here. We're talking about tiny, almost imperceptible drops of urine, frequently trapped against the mucosal skin.
But how does that actually degrade the tissue? Because, urine is mostly water, right?
It is mostly water, but it also contains urea and metabolic waste. When those tiny drops sit on the skin, the urea breaks down into ammonia.
Oh, I see where this is going.
Right. That drastically spikes the local pH, which completely strips away the skin's protective acid mantle. The alkaline environment damages the lipid barrier, driving intense localized oxidative stress. It's essentially a chronic, low-grade chemical burn occurring on a microscopic level.
That sounds incredibly painful. So we have mechanical friction and chronic chemical irritation breaking down the tissue.
Hmm.
But we also have to factor in hormones because LS operates on a very specific, undeniable timeline in women.
It does.
The incidence peaks right before puberty, and then it surges again post-menopause.
And those two life stages are united by one major biological factor: significantly low estrogen levels.
Yeah.
Estrogen is not just a reproductive hormone, it's critical for maintaining the structural integrity of the skin.
How does the drop in estrogen mechanically alter the vulnerability of the vulvar skin, though?
Well, estrogen drives blood flow, collagen production, and hyaluronic acid retention. So when estrogen levels plummet, the tissue literally changes. The epithelium, the top layer of the skin, thins out dramatically. It loses its elasticity and its robust lipid barrier.
It essentially turns into fragile tissue paper.
Exactly. And when the skin is that thin and completely devoid of its protective barrier, it becomes infinitely more susceptible to the mechanical friction of a bicycle saddle or the chemical irritation of microincontinence. The low estrogen doesn't cause LS directly, but it sets the stage. It makes the skin incredibly fragile.
Man, the dominoes are really lining up here. The thin skin gets irritated by friction or urine. That irritation causes profound oxidative stress. The oxidative stress rips apart the cells, unmasking the ECM1 protein. And finally, the immune system spots the unmasked protein, misidentifies it as an invader, and launches the T-cell attack.
It's a brutal chain reaction.
It really is. But before we finalize this model, I have to ask about one more category of triggers mentioned in the guidelines infections. I saw references to the Epstein-Barr virus and, strangely, Lyme disease.
Yeah, that one is surprising.
Right. How on earth could a tick bite lead to a localized genital skin condition?
Well, the Lyme disease connection is heavily debated and largely geographically isolated. Some European researchers found traces of Borrelia burgdorferi, the bacteria responsible for Lyme disease, in tissue biopsies of LS patients.
But wait, did other studies find that?
No. Studies conducted in the United States have entirely failed to replicate those findings.
Ah, okay. So it's likely a regional correlation rather than causation, like people in certain heavily forested parts of Europe happen to get tick bites, and some of them also happen to develop LS, but the tick didn't cause the skin condition.
That is the prevailing consensus regarding Lyme, yes.
Yeah.
The Epstein-Barr virus, or EBV, presents a much more mechanistically plausible connection, though. EBV is notorious for triggering systemic autoimmune responses in genetically susceptible individuals.
Wait, that's the virus that causes mononucleosis, right?
Yes, exactly. When EBV reactivates in the body, it causes a massive surge in systemic inflammation. It wouldn't be the direct cause of the genital lesions, but it acts as a systemic stressor. It elevates the overall inflammatory burden in the body, which could easily serve as the spark that tips a genetically vulnerable person into a full-blown autoimmune flare.
Okay, let's step back and look at the entire board. We set out on this deep dive to answer a specific, crucial question for you listening. Is lichen sclerosus actually an autoimmune disease?
And based on the totality of the clinical, genetic, and molecular evidence we've unpacked, the most accurate answer is that LS is a complex, multifactorial condition that heavily utilizes autoimmune mechanisms.
So it isn't just one thing.
No, it requires a perfect storm.
A perfect storm.
That's
So you
just-
start with the genetic blueprint. Perhaps you inherited that HLA-DRB1 variant. That serves as your dry kindling. Your immune system is naturally prone to misidentifying targets, especially if you're a woman with a history of thyroid issues.
Exactly, but the dry kindling rarely spontaneously combusts. It requires an environmental spark to ignite the reaction.
And that spark is the localized tissue damage. It's the chronic friction from a horseback ride, the localized chemical burn from microincontinence, or the severe thinning of the skin due to a drop in estrogen during menopause.
Right. That mechanical or chemical spark drives oxidative stress into the tissue. The cells rupture, exposing hidden proteins like ECM1. Because your genetic kindling is already primed, your immune system wildly overreacts to the debris.
The microRNA 155 cuts the regulatory brakes.
Yes, the inflammatory T cells swarm the area and you are locked into a chronic, self-perpetuating cycle of inflammation and structural scarring.
For you listening, understanding this exact mechanism isn't just an exercise in academic curiosity. It profoundly dictates how you manage the condition. If you or a loved one receives this diagnosis, this perfect storm model explains exactly why the standard treatment ultra-potent topical steroid creams is absolutely necessary. You have to force those localized killer T cells to stand down to stop the scarring.
But it also reveals why relying solely on a steroid cream will often fail in the long run. If you only suppress the immune system, but you continue to allow the environmental sparks to strike the skin, the fire will eventually return.
You have to address the whole storm. That means modifying clothing to eliminate mechanical friction, utilizing barrier creams to protect against the chemical irritation of microincontinence, and potentially discussing localized estrogen therapy with a doctor to rebuild the structural thickness of the skin.
Furthermore, because of the undeniable systemic autoimmune link, particularly for female patients, receiving an LS diagnosis should be an immediate flag to evaluate your broader systemic health.
Definitely.
You should be advocating for your doctor to screen your thyroid function and check for other overlapping autoimmune markers. You cannot treat this strictly as an isolated skin issue.
We started today by talking about how we desperately crave a clean, binary diagnosis. Lichen sclerosus denies us that simplicity. It's an intricate, deeply intertwined dance between your genetics, your environment, and your immune system's attempt to heal you.
And while that complexity makes it incredibly difficult to diagnose and treat, it also offers a profoundly provocative thought for the future of medicine.
Oh, tell me.
Well, currently, our primary strategy for autoimmune diseases is to develop increasingly heavy-duty drugs designed to suppress the immune system. We focus all our energy on stopping the arsonist.
Right, but if we know that mechanical friction, urinary acidity, and localized oxidative stress are the necessary sparks that unmask those hidden proteins and trigger the cascade.
Exactly. What if the future of preventing localized autoimmune flares doesn't lie in immune suppression at all? What if the key is radically reinforcing the physical and chemical barriers of the body before the immune system ever gets confused?
Wow. Imagine manipulating the local skin microbiome to permanently buffer against pH changes from urine, or developing advanced topical antioxidants that instantly neutralize oxidative stress the very moment friction occurs.
It's entirely possible.
If we can build an impenetrable wall, the hidden proteins stay hidden. We put out the spark before the kindling ever catches fire, leaving the immune system blissfully unaware. The diagnostic waters finally run clear. It's an incredible reframing of how we protect the delicate barrier that is our skin.
A fascinating paradigm shift to consider as the research evolves, for sure.
Absolutely. Thanks for diving deep with us today.